Alrighty, in this video, we're going to be talking about 2.1 and 2.2. To start off with 2.1, we're going to talk about how to organize data. We'll start off by organizing data with a frequency distribution. When we first collect data, it is what we call raw data. Unorganized and rather pretty messy. In example two, we'll see here at ages of wealthiest people. And so suppose we collect the ages of the top 50 wealthiest people in the United States, according to Forbes magazine in August 27th of 2016. With this link, you could update this list over time, but we're just going to keep it as is. All right, so these are the ages of the top 50 wealthiest people. You can see it's not in order. There's no certain pattern to it. It's just we just went from the top 50 to the like from number 1 to number 50, right? Number 1 is 60 years old, followed by 80, then 85, and so on. So that's about the only situation there. All right. So with that, it says a researcher wants to organize the data set into a frequency distribution showing classes and frequencies. Each data value is in a category called a class. The frequency of a class is the number of data values in the specific class itself. So for quantitative values like ages, the classes must have equal width, include values between the highest and lowest value called the range, and have values in at least the first and last class. You can have some empty classes in the middle, but just the first and last class must have someone in it. Keep in mind that classes do not overlap. That's huge, right? So for instance, if I wanted ages between 1 and 10, the next age group would be 11 through 20, right? The 10 and 11 do not overlap. People can only go into one class. So for starters, we'll select the number of classes desired and the beginning value. Since 32 is the least data value, we will begin with 30. So basically that just means that 32 was one of the numbers. It was the smallest number we could see. And to keep things simple, we just happened to choose 30 as the first lower class limit. We see that if you take the highest number or the oldest age of 98, and you subtract that from the youngest age of 32, we get 66. So the class width will say for 6 classes, and again, this is completely random. We're just coming out with some good numbers. So we'll say 66 divided by 6. So really, once you get this total here, just simply figure out a number that goes into it nice and evenly. So we see that 66 divided by 6 is 11. So each class will have a width of 12. And so you just always do one more on top of that. So basically what that means is to have 11 or 6 groups with an equal amount of 11, we have to go to 12 to include that first number. So we'll do 30 plus 12. So that would become 42. So the first class then will range from 30 to 42. Then we keep going. The second class begins at 42. So that means that from 30 to 41 will be the first class. 42 will begin the second class, and from 42 to 53, and then from 54 to 65, and then from 66 to 77, and then from 78 to 89. And then notice that at a seventh class, it will begin at 102, which is way larger than 98. So we don't need that next class. We would have 6 equal classes with 11 as the number. All right, so here we go. So to start off this tally, we have numbers from 30 to 41, 42 to 53, 54 to 65, and 65 to 77. So actually what I think I'm going to do is, let's see, I want to pull this up again so you can kind of see how I process. Oh, it's not going to let me. All right, how about this? I bet I could do this. Hold on. I want you to see my process of what I do. There's no right or wrong way to do something. As long as you're just calculating your tallies, is what it basically comes down to. All right, so here's our original box of numbers. We're going to begin our first frequency distribution. Oh, let me get it over here. There you go. So there's our number. So this is how I like to portray this. All right, I want to do all the numbers as I go from left to right. So I'm going to go 60. 60 falls between 54 and 65. So here we go. We put a tally. And then I cross it out. Then I go 80. Here's one. Cross it out. 85. Here we go. 52. There's another. 32. Here we go. 72. Right there. 76. 74. 80. 76. 93. 43. 43. 67. So you'll see there, the moment I got 5, I make it a block. 68. 71. 66. Notice also here, when I have 66 right here, it only falls into one category. That's why you cannot have overlapping. 62. 77. 88. 83. 60. 51. 59. 78, again, fell in that one category. 98. 86. 88. 76. 80. 44. 59. 65. Again, fell in that one category. 68. 54. 51. 51. 76. 59. 63. 67. 52. 77. 61. 73. 50. 61. 62. 50. And then 61. All right, so that's a tally system. You literally just kind of go through, marking each one off so you don't forget about it. And after that, you just add them up. So frequency, again, just means how many times in that class did it happen. Well, between 30 and 41, there was one person. Between 42 and 53, there were 10. Between 54 and 65, there were 13. Between 66 and 77, there were 15. Between the age of 78 and 89, there were 9. And between the age of 90 and 101, there were 2. Always check to make sure you got to 50. So we got 11, 24, 39, 48, 50. So we definitely got 50. We didn't forget any numbers, but that does happen. All right. So now, there you go. Now we got those numbers. You've done your first frequency chart. All right, so classify each data value in a class using tally marks, then count the tally marks to find the frequency of each class. The results can be shown in a frequency distribution with 2 columns, leaving out the tally marks itself. So you don't have to do tallies, but definitely helps, especially when there's a lot of data. After that, we want to organize our qualitative data using categorical frequency distribution. This is for only the name. So data that can be placed in categories such as nomial or ordinal data can be organized using a frequency distribution. So maybe we had 50 people and maybe we were looking at low, medium, or high income. So then all these 50 people would either have, let's say, L, M, or high or H. And then that would be a qualitative categorical frequency chart to figure out how many people out of 50 rank in each income family. But the example they went with was so in example two, blood type. So 25 Army inductees were given a blood test to determine their blood type. The data set is this right here. So they're either A, B, or O. We're totally ignoring positive and negative. This data here would be an example of categorical. There's no number value, but they are able to fall into some category. All right, so again, the data is categorical, so discrete classes, one for each blood group, can be used. We don't have to come up with a class range. We would just have A, B, and O as our classes. So step one, we would make a table showing the class frequency and percentages. Step two, you would count the frequency of each category, use the tally marks if needed. Step three, we would find the percentage of values in each class by dividing the frequency of each class by the total number of values. And then step four, find the total in each column. So what they did here, they did a lot of this work for us, but we'll have examples that we'll do as well. So there were 5 people with an A, so there's 5 A's. There were 7 B's, 9 O's, 4 AB's with a total of 25 people. Again, you always want to total that up to make sure you got the right amount. To get the percentage, all you got to do is take the frequency, divide it by the total times 100. So 5 divided by 25 times 100 gives us 20%. 7 divided by 25 times 100 gives us 28%. 9 divided by 25 times 100 gives us 36%. 4 divided by 25 times 100 gives us 16%. And then again, always total that all up to make sure it adds up to 100%. Right? So hopefully that gives you a good example of a categorical, or sorry, a qualitative and a quantitative frequency chart. All right, then we go into what we call group frequency distributions. And this is when the range of quantitative data is too large. The data must be grouped into classes. So we'll decide how many classes to use. There should be between 5 and 20 classes. You want a minimum of 5, but not more than 20. What number you choose between 5 and 20, including 5 and 20, is completely up to you. Again, what I like to do is look at my range and then go, which number between 5 and 20 does this number go into evenly? I like to keep my numbers small, so I start off with 5, 6, 7, and keep kind of going through until I can find something. Again, numbers do not need to overlap. All right, so the lower class limit, again, is the smallest data value that can be included in a class. Remember, the first class and the last class must have at least one person in it. Thus, the first lower class limit must be no larger than the smallest value in the set. So earlier when we chose between 30 and 42, 32 was able to fall into it. So we can't have anything less than 32 because then we wouldn't be able to put the smallest setting in there. All right, so with that all said, you want to find the upper class for each class. So find the upper class for each class. This is the largest value that can be included. So that's when we divided it by 6, we got 11. So then we were like, all right, well, 30 plus 11 gives us 41. So 30 to 41. 41 would be that upper class limit for that class range. This is the largest value that can be included in each class. Class boundaries are the numbers used to separate the classes. The size of the gap between classes is the difference between the upper class, a limit of one class, and the lower class of the next class. The class boundary is the midpoint of the upper class limit of one class and the lower class limit of the next class. So had we had people that started going, well, I'm 6 months old, right? We would then say that would have been 41 and a half. And then the next group would have started at a 41 and a half as well. But one would have been like 40 point 41.5.1, or not too many points. 41.51 would have been fallen into the next category had we had something with decimals. Right. So again, class boundaries, the midpoint of the upper class of one class and the lower class limit of the next. So if the data values, again, are whole numbers, we find the boundaries by adding and subtracting 0.5 from the lower class and adding the 0.5 to the upper class limit. So here we go. So that lower class would be, what was that, 30 minus 0.5. So it'd be 29 and a half as the lower class boundary, and then 41.5 for the upper class boundary for that one set there. So if the data values are in the tenths, then we would add and subtract 0.05 from the lower and upper class limits. All right, so the class width is the difference between the lower class and one of the classes and the lower class limit of the next class. So it is preferable that the class width be an odd number to kind of help you out, but it's not always the case. All right, so the class midpoint is the average, again, of the lower and upper class limits, or the upper and lower class boundaries. The midpoint is the numeric location of the center of the class. So what I would be looking for is the number between 30 and 42, which I believe would be 35 and a half. I mean, between 30 and 41 would be 35 and a half, right? Because that would be 5 and a half. Yep. So it'd be 35 and a half would be the center of the class range. So for a class with a lower limit of 24 and upper limit of 30, again, you would just add the 2 and divide by 2. So we see 27 would be the center of the data. So that's, again, just trying to find the midpoint of a range of class. All right, to construct a grouped frequency distribution, we're going to follow these rules. There should be between 5 and 20 classes. It is preferable but not necessary to have a class width that is an odd number. Classes do not overlap. So no data values can be in two classes. Classes are continuous, and there must be enough classes to accommodate all data values, meaning everything that's in your set should accommodate, but you shouldn't have your first and your last groups should not be empty. Class widths are equal, so that'd be the sixth thing. And is there more? Yeah, so there's another thing here, but class widths should be equal. I say should, are equal. Like there's 11 in this number, 11, so like 30 to 41, 42 to 53, and so on and so on and so on. Just like we saw in that example, they must be equal. So as you can see, again, class widths are equal. All right, let's look at this third example, talking about salaries of colleges and university coaches. So the data, again, are salaries in hundreds of thousands of dollars of a sample of 30 colleges and university coaches in the United States. We're going to construct a frequency distribution for the data using 8 classes. All right, so these are, again, this is someone making 164,000 all the way to someone making 515,000. Again, not in no specific order, just 30 different sets. So to find the range, we have to take the highest value minus the lowest value. So what you want to do is kind of look at the data and go, all right, which one is the highest value? And kind of looking at it, the highest I see is 857. That's going to be 857 minus the lowest value I can see looks to be about 140. So when we take these two and we subtract it, we get 717. So now we're going to determine the class width by taking the range, which was 717, and divide that by 8. Type it into a calculator and you get 89.625. What we're going to do is going to round up to the nearest whole number. And so we'll say that this is just going to be 90. So that means the range is going to be 90. All right, so this is what we've done. Find the class limits. This is what we're about to do, sorry. We're going to find the class limits. We're going to find the class boundaries. We're going to find the midpoint of each class, find the frequency for each class. We're going to compute the cumulative frequencies, showing the frequency of values less than or equal to the upper class boundaries of a specific class. Compute the relative frequency, the quotient of the class frequency, and the number of data values of each class. And then compute the cumulative relative frequency, the quotient of the cumulative frequency of the specific class, and the total number of data values for each class. Now that sounds like a lot, but it really isn't. Once you start analyzing data, it's just the stuff that makes the most sense. So this is what will wrap up 2.1 before we get into 2.2. So let me go ahead and clear up some data. All right, I'm just going to copy this so I can come over here. I want to paste this. There we go. Put this number so I can see it all. Move this number so I can see this. All right, here we go. So now I can kind of do both of these at the same time. So again, those are all the things we're about to do. I know it sounds like a lot, but it really, again, isn't too terrible. And really and truly, once I get the frequency here, I really don't need this too much anymore. So again, we decided we're going to do 90 as our class number. So if you were to do 140 plus 90, again, quickly do a calculator here. Let's pull up this one. 140 plus 90, you would get 230. So 230 would be the next number. So this would be 230 right here. And then if you want to do that plus 90 again, you can almost see a pattern here, but you would then get 320. And then this would be 410. Then this would be 500. Then this would be 590. And then this would be 680. And then this would be 770. And then from there, that means that this would be 319. This would then be 409. This right here would be 499. This right here would be 589. This one right here would be 679, 769, and then this would next one here would be 860. So we can say then this would be 859. All right, after this point, to find the class boundaries, all we have to do is subtract 0.5 from the lower limit, add 0.5 to the upper limit. So you'll see that this will now be 229.5. These will be the same, minus 319.5. These are just the boundaries. All right. Again, this would then be 319.5 to 409.5. Then this is 409.5 to 499.5. And then this would be 500. Nope, I lied. This would be 499.5 to 589.5. And this would be 589.5 to 679.5. And this would be 679.5 to 769.5. And this would be 769.5 to 859.5. right? And then the midpoint is literally the number right in between it, right? So the way we do this, oh, let me get this over here. Just so you can see, they'll do 140 plus 229, divide that by 2, and you get 184.5. So if we keep doing that, that'd be 230 plus 319, divide it by 2, and we get 274.5. And if we keep this going, you'll see a pattern here in just a second. 320 plus 409 divided by 2, and you get 364.5. Hopefully you see the pattern at this point, and you are now saying, well, this is going to be 454.5. And then this right here would be 544.5. And this would be 634.5. And then this would be 724.5. And then this right here would be 814.5. Right? Because it's the same amount of difference, the pattern should also show here. Right? Now that we've done all of this pre-work here, now we're ready to do the frequency. And once we do the frequency, I'll no longer need this chart over here. All right, so here we go. I'm actually, again, going to do a tally. So what I'll do is I will do... There's only 30, so I'm going to do like a tally here, and then I'll write the result over here. There's not a section for tallies, but it definitely would help to do that. All right, here we go. And I'm going to add it into here as well to make sure they're right. So 164 falls right here. So that one's out. 210, there's no specific way to do this either. Oh, there we go. All right, so 210 falls again right here. 550, 478, 857, 450, 225, 238, 188, 684, 183, 385, 225, 146, 415, 330, 381, 297, 140, 201, right there, 261, 307, 275, 390, 188, 544, 164, 435, 578, 515. All right, so this definitely is 11. This will give me 5. This will give me 4, 4, 4, 0, 1, 1. All right. So again, I do think that tallies are real useful, especially with, I would say, light amount of numbers here. So here is our frequency, 11, 5, 4, 4, 4, 0, 1, 1. All right. And that does all total up to 30. All right. So now I don't need this anymore. Let's see if I'm able to, or if I could pick up things. Let's see how easily I can transition here. It does not allow me to pick those things up. Well, tartar sauce. You know, what if I'm able to Nope, that's not helping. Okay, here we go. Nope, that didn't help. All right, so let's just say these are in the right spot. So y'all have been writing it down as I was going on. So I'm going to fill these spots because these are really the numbers that I need now. All right, so there you go. So 11, 5, 4, 4. Oh, that's why I was off by 1. 4011. All right, so here we go. So a cumulative frequency is basically saying what falls in this class and all above it as well. Maybe if it's still throwing me off. At least, there you go. I can at least do that part. All right, so let me erase this. Just OCD's coming in here. All right, so again, that's 11. 5444011. All right. So all that has to total up to 30. Cumulative frequency is just that category and the categories before it. So this class right here only had 11. But in this next class, I have 5 plus the 11 before it. So now I have 16. And what this is basically stating is I now have 16 people that fall between 140 and 319. And then I would accumulate the next one. So this would be 20. And again, what this number is stating is I have 20 people that fall between 140 and 409. Or you could even say I have 20 people that are 409 or less. And you kind of keep on with that pattern. So this would be 24. This would be 28. This would be 28 again, 29. And then you would finish with 30, basically stating that 30 people are 800 has a salary of 859 or less. So that's cumulative frequency. You just take and you add the previous classes with it. All right, relative frequency, you would just take these numbers and divide it by 30. All right, so when we do that, you would do, again, I'll do a couple so you can see what kind of math. I'm just pulling up a regular old calculator here, but you would just do 11 divided by 30 and round that to about 0.37. I would then do 5 divided by 30 and I would get 0.17. Again, I would round. So this would become 0.17. And then you keep that pattern going. This would then be 0.13, 0.13, 0.13. This obviously is 0. This right here would then be 0.03, 0.03, and all of these numbers should add 1. Again, go through there. Maybe there's a rounding thing. Maybe you need to uptick or downtick some numbers to get it to add up to 1. A cumulative frequency, you're now going to take these numbers divided by 30. So again, 11 divided by 30 gives us that 0.37, but now to get the next one, I would do 16 divided by 30, and I would get 0.53. So again, 53% of my data has a salary of 319 or less. And then you do 20 out of 30, and now you get 0.67. So again, 67% of my data gets a salary of 409 or less. And then you do 24 out of 30 and you get 0.80. Then you would do 28 out of 30 and get 0.93. And again, this would also be 0.93 because this didn't change. And then the next one would be 0.98. And then, of course, the last one, 30 out of 30, would be 1. So this just shows us the percentage of our frequency. I can see right off the bat after my first 2 classes, that's over half my data alone. So you can definitely see that potentially our data is skewed more towards the lower salaries, and the higher salaries are almost outliers, right? We had that one person that made between 770,000 and 859. I used to joke that this was just oh man, the name has already thrown off. After he retired, I done forgot his name, but it was the Alabama coach, right? He probably was that number that you were looking at. All right, so then that is how you do a frequency distribution chart. Right, so that right there concludes 2.1, but in this video, I'm also going to go over 2.2. So in 2.